This week on Quality Digest Live, we chat with author, trainer, and auditor Dan Nelson.
Plus, considering the limits of the Gemba, that and more when we come back.
Today's sponsor of Quality Digest Live is HEXAGON METROLOGY. HEXAGON carries the widest range of quality brands. With an extensive support network, HEXAGON is also your partner. HEXAGON Metrology. We are metrology.
Well, welcome back to Quality Digest Live for March 14th, 2014. Hey, you know what today is?
Pi Day.
It's Pi Day, that's right, 3/14,
you.
There you go. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
And I'm Quality Digest publisher Mike Richmond. Okay, we're going to start the show this week, not necessarily with Pi News, Pi Day, but with an interesting piece of people news. The American Society for Quality has named a new CEO, and when you look at this man's background, you can see that lots of vision and leadership come with him. William Troy will assume the position of CEO for the ASQ on April 21st, replacing Paul Borowski, who's retiring after 27 years of service with the organization. Retired Lieutenant General with the Army, Troy's most recent position was Director of Army Staff at the Pentagon, where he had oversight of more than 20,000 soldiers and civilians. So clearly, Dirk, I think this is a guy that knows how to lead. A lot of people that he's had experience with leading. In addition to that, Troy has extensive experience in developing and executing strategic vision, and he's also an exceptional relationship builder with an international background, working with a variety of military, political, and business leaders. The ASQ, of course, is our industry's leading professional organization with members in 150 nations around the globe. Troy will push to maintain this ever-expanding international focus for the organization. Now more than ever, as global trade connects and further reaches into the earth, there's a growing need to understand quality frameworks and processes, and I think Troy has the perfect background to do just that. Again, Army guy, a lot of years of experience leading big organizations. Yep. Paul Borowski, great guy we've had on the show before.
Oh yeah, for sure.
Hopefully we'll have
Troy on,
Mr. Troy on the show at some point going forward as well. I think this is a really good move for ASQ. So for more information on this news piece and all the pieces that Dirk and I are going to be covering on today's show, please be sure to check out the story links right below the video player screen, as always, right down there.
That's right. Well, we are in an era of wondrous new inventions,
yes, we
ideas, and achievements. So writes MIT Sloan professor Eric Brynjolfsson and research scientist Andrew McAfee. But all that wondrousness comes with a drastic reorganization of work, finance, and society. Brynjolfsson and McAfee discuss this topic in their book, The Second Machine Age, Work, Progress, and Prosperity in a Time of Brilliant Technology. This book guides you through the forward march of progress and innovation, which we've all have experienced, but whether this brave new world is a good one or a bad one is up to us, say the authors, because, according to Brynjolfsson, quotes, a big part of what's going on is that technology is racing ahead of our skills, our organizations. Our economic institutions aren't keeping up, and that's leading to a bigger and bigger mismatch, a grinding of the gears. And there are two economic phenomena that have appeared alongside advances in technology, according to the authors. The first is bounty, essentially the idea that there is more wealth. And the second is spread, which is bounty accruing unevenly. We've all heard about this, the rich steadily getting richer, while the poor and middle class struggle to maintain or improve their standard of living. Of course, unemployment is usually also part of the picture whenever new technologies take hold. So, what to do? The authors suggest some ideas, though not actually endorsing all of them. They're just ideas. And some of those ideas are like taxes on negative consequences from technology. Think, pollution and the like. Negative income taxes, where the poor are given money from the government. And the idea here, I guess, is that technology took your job, so we need to give something back. Now, like I said, these aren't ideas that that they're necessarily endorsing. They're just kind of brainstorming. And the problem with those two ideas, by the way, is that they're at the wrong end of the problem. They're Band-Aids. More concrete are the author's calls for investments in education, entrepreneurial growth, regulatory reform, government-supported scientific research, and so forth. This is stuff is more proactive. It's trying to deal with the problem of technology outstripping our skills before really it gets out of hand. So interesting article. Go click on the link to read the article and actually go take a look at the book. It sounds very interesting. Actually, I'm going to pick it up myself.
Yeah, I think that's good stuff because we so often talk about the technologies and there's repercussions to all that, as we know.
Sure.
And you have to be mindful of that too. I think Bill Levinson's done a good job talking about some of these issues.
Right,
as well.
and what the authors are saying is that basically they have to, society has, and our organizations and so forth have to track with the advances. Otherwise, technology gets too far out in front of you, and there are negative consequences, and then you're stuck with having to put Band-Aids on them.
Yeah,
So.
and you have some people benefit greatly and others just
Right.
get left behind. So it's important issues. Good stuff. Thanks,
Yep.
Dirk. All righty. Well, we've got an interview for you now. We're going to start with our features with an interview with one of our more recently added regular columnists, and he's quickly become one of our favorite and most popular ones. I think he's been one of the more favorite ones with all of you out there as well. Dan Nelson is a quality management consultant, author, and trainer specializing in the process approach to improvement with a focus on ISO 9001 and related sector-specific schemes. Dan is never afraid to question conventional wisdom, and his latest article, Does ISO 9001 Certification Remind You of Spoiled Milk?
No, really, what are you trying to say there?
And that appeared in Tuesday's issue of Quality Digest Daily. You just saw it right there on the screen, and that article certainly is no different in terms of challenging conventional wisdom. So, to chat now more about that article and a lot more on top of that, we're pleased to welcome Dan Nelson to the show. Hello, Dan.
Hi, guys. Happy Pi Day. Thanks for having me along.
That's right. Happy Pi Day.
Happy Pi Day.
3.14 to you too.
That's right. Thank you, Dan, for joining us. Well, you know, your article was a good one that we ran earlier this week, and you talk about comparing registration to ISO 9001 to spoiled milk. That's kind of an interesting analogy. I wondered what made you think of that, and what does it mean?
Well, sometimes it's hard to see the humor in a situation when you're so close to it, and people who are in the grind that they've come to can't quite see the humor in it, so you have to back out a little sometimes and put it in context to where you can actually laugh at it, and at that point I think you even understand the problem a little better. So I guess the analogy means we need to throw out the rotten milk and replace it with something healthy.
And I think what you're referring to by rotten milk is not so much ISO 9000, but the way it's implemented in some companies, right?
Right, and it was a snowball effect. Some companies early on got certified by using a standard-based approach. That is, they developed their quality management system around the requirements of the standard instead of recognizing the system that's already operating to put out quality product every day. So with this idea that they're supposed to raise systems to meet the requirements of ISO 9000, it spoils the whole experience, and it doesn't result in an effective quality management system. So it's time to throw out that spoiled milk and replace.
Did we lose Dan?
On quality management.
Okay.
So Dan, we lost a little bit of you there, but I think I got what you were saying, that this idea that you know there's a better way of doing this, and you know you're a process-based guy, and the usual way that organizations register and are audited to a standard like ISO 9001, it can be considered a process, and many people would say, well, it works just fine. So why do you think we need to reinvent it?
Well, I don't think we need to reinvent it. We just need to improve it to the point where it's effective. Standard-based systems really shouldn't pass ISO 9001 certification. They do just as easily as process-based systems. Well, the standard requires a process approach, and a standard-based approach doesn't demonstrate the process approach as required. So it's like we have a go, no-go cage that's stuck on go. And so the standard, when it's applied properly, should kick out systems that don't meet requirements, yet here systems that don't meet requirements are passed just as quickly as those who do.
Well, you know, I'm glad you said that, because I think a lot of people are still confused about the basic intent of ISO 9001. It's pretty common. We hear it. The prevailing opinion often seems to be that the standard exists to help companies design or implement procedures to manage their quality, but that's not really the point of ISO 9001, is it?
No, the idea that to be implemented came along with the idea to get certified. And people got the idea, well, the objective is to get certified. And so, as I said, they developed systems to answer the individual requirements of ISO 9001 as if ISO 9001 itself was supposed to be implemented by management in their organization. But ISO 9001 is supposed to be implemented or put into use by auditors when they use it as audit criteria. So the standard presupposes quality management or a quality management system was in place before the standard is applied to it. When we allow the standard to identify or to define our systems, we've put the cart before the horse.
And so essentially what you're saying here is I think that the standard exists for assessors, auditors, to look at it and assess whether or not management is in fact managing their company properly. It doesn't exist so that management can follow a kind of a prescripted series of steps and say this is the way that you implement quality in your company. Is that a fair statement?
I think that's fair. I think that's just right. I don't know what really to add to that. I think you hit the nail on the head there, Mike.
Well, do you think some of the confusion comes from the fact that users think that a QMS and ISO 9001 are the same? Because I mean, I often heard this. Matter of fact, I think we've even put it that way in some of our articles. You know, your ISO 9001 QMS. Yeah. I mean, is that kind of smooshing terms together?
I think so. They're two different things. The quality management system is the important thing to any organization. That system was in place before ISO 9000 ever came along. But when ISO 9000 came along to require documented procedures, people chose to document their procedures according to the standard and its subclauses and its clauses instead of documenting the system as it sits and operates every day. And that confounds the definition of the system to where it's not even a management system. A quality management system actually outputs product. So a process-based, to document that system with a process approach, you would dedicate your procedures to the processes. The procedure serves as the plan for each of the processes. There's a way management wants it done. And when we define the way we want it done according to the individual requirements of ISO 9001, we don't succeed in describing how we want it done. We only succeed in describing how we conform to individual requirements of the standard. So basically, what happens is an understanding of ISO 9001 serves also as an understanding of quality management. And so that forces everyone to look at quality management through an ISO 9000 checklist instead of looking at the system for what it is.
Right, and the trap that you fall into there, if I understand it properly, is, again, getting back to your spoiled milk analogy, that people do it the way that they think it's supposed to be done, and they need to experience that for themselves, even though, you know, people say, it stinks the way that we've had to do this, but it worked, we got certified. So I think what I'm hearing is that it's this thing we talk about a lot, that people look at ISO 9001 and they say, well, I need the cert on the wall, as opposed to understanding that the value of it comes from the process you go through to enrich and improve your company. Is that fair to say?
I think that's right too, yeah. The value of the quality management system is being clear about how processing is supposed to occur, so that you can check to first make sure it's done that way, and second, to improve that process, improve that plan by application of the do, check, act moments of the PDA cycle. If you don't define your process, your plan for processing up front, it's awful hard to improve upon that plan if it was never defined in the first place.
Mm-hmm. Good stuff. Well, thanks, Dan. You've been one of our very popular newest additions to our stable of authors. I thank you for joining us today. We definitely want to have you back. We're looking forward to a lot more articles from you coming forward in the next few months. So thank you again for joining us today, Dan.
Thank you for having me, guys. Have a good rest of your Pi Day.
You too.
You too, Dan.
We'll talk to you soon.
All right.
Okay, thank you.
Thanks, Dan. Good stuff there from Dan. Yeah, enjoy that. He's got a really interesting perspective on ISO 9001. I think you heard some of it there.
Very realistic and down to earth.
Yeah, I think it's practical. I think you guys should all check him out there.
Yeah. Well, another new columnist for us anyway is Donald Reinertsen. Some of you may have heard of him. He has got some great blogs on his website, reinertsenassociates.com, so you should go check that out. This week we ran a column of his called Going to Gemba and Its Limits. And in the article, Reinertsen is basically trying to make the case that going to the Gemba, the place where work is done, makes sense for something like manufacturing, but maybe not so much sense for something like engineering. And by the way, let me add here that according to our columnist Mike Mickelwright, the more formal term for Gemba is more Genchi Genbutsu, which means go to the place to understand the situation. The distinction here is significant, and I will get back to that in just a bit. So, Reinertsen starts off talking a little bit about Taiichi Ohno and the Ohno Circle. And if you remember, Taiichi Ohno was the Toyota's VP of manufacturing and the genius behind the Toyota production system. And if you haven't heard of the Ohno Circle, basically the legend is Ohno would go out and draw a chalk circle in the middle of the manufacturing floor, and he'd make a manager stand in there for sometimes a very long time. And the goal was the manager was to observe what was going on in the manufacturing area. And the longer they stood there, of course, finally things start to seep in. They start to see kind of the ebb and flow, the movement of materials, the movement of people. They begin to get a feel and to notice maybe problems in the manufacturing system. Maybe they're seeing waste, waste and movement and that type of thing. So that was the value of the Ohno Circle, and it was very visually oriented. The problem, says Reinertsen, is if you try to apply this to engineering, you can't see what is in an engineer's head. You can't draw a circle in the engineering bullpen and understand what problems did the engineer have to overcome, what alternatives did the engineer have to consider, which alternatives were discarded and why, how much margin is there in the design, where's the margin been allocated, and so forth. This stuff is all inside an engineer's head before pencil ever meets the paper. So Reinertsen says, going to the Gemba, as he defines Gemba, just doesn't make sense. You can't see these things. So he harkens back to MBWA. Any of you from the 70s or 80s remember MBWA, managing by walking around. Now, I was working in manufacturing during MBWA, and I can tell you there was a lot of chuckles. You'd see a manager come out to the floor and start walking around, and I'll be kind of nudging each other. Hey, MBWA, yeah, right, yeah. Walking maybe, but not necessarily managing. But his point is actually done right, MBWA is very important. And he kind of talks about Bill Hewlett and Dave Packard and how they did it. And they would go into engineering and they would talk to the engineers. They would share the company's mission and vision and its goals and engage the engineers in telling them, what are the roadblocks to what you're doing. In other words, get a feel for what the engineers are doing, something, and what the problems they're having, something that you can't get just by watching, right? And Reinertsen says, if product development, he kind of finishes up the article, he says, if product development is your game, don't think that going to Gemba is going to solve your problems. It won't even identify them. Almost nothing that is truly important is visible in the physical environment of engineering. Critical issues like batch size, overlap of activities, sequencing of tasks, margin in the design, architectural partitioning choices, and risk management strategies are not apparent by observing the physical objects. You would be better off emulating Bill and Dave. And here's where I kind of diverge from him. Reinertsen, he's right. He's right about the importance of engaging everybody, including your engineers or your financial staff or your software developers, because you can't see what's going on by looking at them. The problem is he's wrong if all you mean is look. But going to the Gemba isn't about looking. People sometimes associate Gemba with it all being visual, but it isn't just visual. It's touch, it's listening, it's tasting, it's talking and listening. And this is really interesting. Let's get back to what I mentioned earlier about Toyota and Genchi Genbutsu. Toyota's own definition, as expressed in the Toyota Way 2001 internal pamphlet, is this, and I think we have a slide of it. We practice Genchi Genbutsu. Go to the source to find the facts, to make correct decisions, build consensus, and achieve goals at our best speed. Now notice that bit, go to the source to find the facts. It doesn't say anywhere about you're going to look, you're going to touch. It doesn't tell you how to find the facts. It says go to the source and find the facts. Going to the Gemba is not about just going and standing in a circle and visually observing. Certainly there's some importance in that. It is really about getting a feel for the workplace no matter where the workplace is, whether it's manufacturing, whether it's engineering, whether it's finance, whether it's software development. You have to use all of your senses, including listening, in order to go to the Gemba.
Yeah, and it's analogous to me to the idea of kata that we talked about on the show not long ago. This idea that there's forms, there's backup things that you need to have in place first that helps you understand and make critical thinking decisions. Standing in a circle can be considered kata in a form of having the basis of that, the basics of it in place, where you can then begin to apply that to the problems in real time on the factory floor. Really good stuff.
Reiner's is a good writer, by the way. I mean, you should read the article. It's very, very good.
Very well known. Yep. He's been around for some time and has some really good experience. Okay, well, thanks, Eric. That's a really good story. Thank you. And we have another really good piece today to close the show. It's going to be our Tech Corner, and this is going to be Dirk and Sean Parker. Sean of 3D Systems is going to join us today. They're going to be looking at a relatively new product here from 3D Systems. Is it the 3D Systems Capture Scanner? There it is, right there. And I'm going to throw it now to Dirk and Sean. So take it away, guys.
Well, thanks, Mike. As Mike said, I'm here with Sean Parker with 3D Systems. And Sean, Capture, Geomagic Verify, what are we looking at?
Well, happy Pi Day again.
Happy Pi Day 3.14. Can't stress that enough.
So, Dirk, what we're looking at today is the 3D Systems Capture White Light 3D Scanner. And we've also got our first article inspection software package called Geomagic Verify. What we're going to do today is kind of walk through a little bit of an inspection program, set that up, and then we're going to scan this little 3D printed widget that I've created here. And just watch the software work.
Okay, sounds good.
Okay, so what I've got right here is Geomagic Verify. This is, like I said, our first article inspection process. And I've already kind of started a inspection feature tree process here. So basically what Verify is it's a inspection package built on a 3D CAD kernel. So basically the Parasolid kernel, like SolidWorks is built on, is what the software was developed on. And the advantages that gives us for an inspection package is twofold. First of all, we've got this inspection feature tree, and that gives us a really repeatable process for every part that we create. So once I set up my feature tree here, every part that I basically inspect subsequent to this one will have the same process applied to it, so it's very repeatable.
And by feature tree, that's the order in which things are going to be inspected, like the inspection plan sort of thing?
Exactly, that's the inspection plan. It's analogous to kind of your feature tree, your history tree in a parametric CAD package, so SolidWorks, Creo, Pro-E, that sort of thing.
Sure.
The other advantage that being on a CAD kernel gives us is that all of the reference geometry and everything like that is already derived from the CAD body. We don't have to go through and manually set any of that up. So it knows all of our measurements and everything on the nominal. And so that makes it pretty quick.
Okay.
And if we don't want to do that, the other nice thing that we have available to some of our users is if you have a CAD body with PMI already enabled in it, we can import that directly, so you don't have to reset up all of those geometries to inspect. That comes in native with the CAD model.
Okay.
So what I've got here, like I said, is I already kind of started with the inspection feature tree. I've got a couple of alignment processes. I've got a whole deviation to give me a color map of the overall compliance to the CAD body. And the one thing that I didn't set up in here is some GD&T, so I'm going to just show you how quick and easy it is to...
And you've got the full set of GT&T tools, right?
Right. So when I get into my GD&T mode here, I've got all of the, these are all three-dimensional GD&T. I can do section views where I do two-dimensional GD&T callouts as well. But we do support the full set of Y14.5 ANSI standards. So I'm just going to do a real quick datum on this face, place that right there, and you can see as I hover over each individual face, it gives me kind of what that is. I've got a plane, a cylinder, sphere, that sort of thing. And then I'm going to create a flatness callout on that. And I'll just use the default tolerance here. And when I apply this, it's actually going to do a combination datum reference frame right here. One more, I'll just do a quick surface profile.
That's pretty straightforward. You're just dragging, basically clicking and dragging, right?
Clicking and dragging. Just clicking on the face that I want to apply that callout on, and then dragging it out into space so I can actually see where that callout is. So we'll go ahead and leave that here. You can see that when I do add these things, I've got a datum, a flatness, and a surface profile here. So this is all of my nominal value, actual value deviation. This is all the tabulated measurements and everything associated with that. Since I don't have any scan data in there right now, it's not going to be calculating anything, because we'll actually get to that right now. The other thing that we see here is I have some errors saying that I don't have any scan data, so none of this will apply. So let's go ahead and take some scan data. I'm going to go ahead and exit my GD&T mode here. And by the way, I set up a report in the background, so all of this stuff will be tabulated automatically in whatever report template that I decide to generate.
Okay.
So I'll go into my Scanner Direct Control and select the Geomagic Capture. The nice thing that about having this capture system interface with this software is it's all in one. You don't have to go through the scanner's manufacturer's little capture interface and then take the data and then transfer that data in here. This is all just one system.
Okay.
Yeah. So I'll go ahead and connect the scanner here. It takes just a sec. This is all connecting through Ethernet. And it brings up a little preview of what the scanner can see. So if I kind of move this around, you can see in there that it's ready to roll.
And that's to help you aim. That's to help you aim the camera at the target. Is
Basically,
that right?
yeah, exactly. So right now I can play around with my exposure, and I want to take a scan here. So if you can see in the camera, it was very, very quick. Takes a scan, and there's my scan data.
Your first scan, okay.
Yeah, first scan data right there. This is all line of sight. This is a blue light scanner, so it's very, very quick. It'll scan the part in about half a second or so, and then kind of process that data and render it. And if I take a second scan, for example, if I come in here and move this and hit the scan button again, it's actually going to, when it's doing its processing step, it's going to align that with the original scan data. So something like this, where we have real nice prismatic features, you can see that the auto alignment was able to kind of find the similarities between the two scans and perform that alignment.
And if it wasn't to align it, I'm assuming you could manually align scans if it had a hard time auto aligning them, right?
Absolutely,
okay,
yeah.
Sure.
So if there was, if it's kind of a less feature-rich part than that, if there's, kind of wide open space or kind of, big freeform shapes in there, we can do either target alignment, so a paper or a spherical target, or we can also just do a manual kind of a post-process stage later on.
We'll talk about the scanner here just a little bit too. Very small form factor.
Oh yeah, oh yeah.
Lightweight. What kind of accuracy?
So we can go down to about 60 microns at the kind of ideal operating range. The max accuracy issues that we would have would be about 100 microns. So still well within the average needs of the inspecting consumer.
Okay.
And it's a very, very, like you said, small form factor, really sleek, nice aluminum case. It's very portable, very easy to move around.
Okay.
Okay, so I took 2 scans there, and we can see that it already aligned those things for us, but what I could do is continue down that path and just rotate this around.
Keep rotating and getting more scans.
Keep taking all the scans. Like I said, it's line of sight, so you're going to need multiple angles typically. Just make sure that you get all the data that you're trying to inspect, and you're good to go. You'll also notice that it's not in the right coordinate system right now. That's because the alignment processes that I've set forth in the procedure to inspect this part, they haven't actually been ran on this yet. So no analysis has been done. It allows me to take a number of scans, merge them all together into one, and then finally go through that process.
So that's why the scan data is showing up outside of the actual CAD model, which is above it. In
so
what
yeah,
we're
the
seeing
scanner
on
has
screen.
its own coordinate system, and it's not necessarily that of the CAD body.
Gotcha.
So from here, basically what I can do is exit my scan mode, and it's asking me if I want to combine those things and do an alignment process. And if I wanted to, I could do that. In the interest of saving time, though, we can just pretend like
sure,
we've
that we've done all of our scans.
Exactly.
Sure, yeah.
And then I can just tell it to run the inspection process. And what that's going to do is it's going to exit the capture interface here in a sec, and it's going to go down that linear step-by-step process that I already set for. So both of the alignments, it's got that whole deviation where it'll do the color map, it's got a section mode, and then it's got that GD&T. So I'm not going to do it right now because it's just taking, going through that process, whirring away and doing it.
Yeah.
I've actually pulled up another one here. It did run it, by the way, on the limited scan data that we had, but I'm just going to grab one that I already ran just a minute ago, and you can see what we've got. So
obviously this one you did multiple scans to fill in all the shadow areas and so forth.
Exactly.
Okay,
so it's very, very simple. It's really intuitive. It kind of walks you through the process of combining all of those scans together, and then once we have that final merged object, we can run our inspection on it.
Okay.
All right. So what we've done here, and you can see that I've got a few inspectable objects. I've got some annotation tags that I've applied to it. I've got some two-dimensional GD&T, and then like you saw earlier, I set up that surface profile. Once I do that, it inspects it all for me. I've got the nice color map visible. Sure. And then it's got my all my data filled into the tabular view down below with all the kind of statistics and histograms, that sort of thing. Once we have that, we can jump into our report and take a look at the report that we've been spat out here, and then we can save this out or do whatever it is that we need to later. So,
and the report includes both the CAD model and the scan data?
Totally customizable. You can tell it what you want to see. You can set your own report template. You can actually mirror some of the more generic reports out there that are kind of required by vendors and that sort of thing. Sure. It just requires a little bit setup on the front end, and once you have that one set up, you can apply it to all of the different parts that you're inspecting. So we've got some just standard views of our CAD and our scan body. We've got the histogram and some of the statistics of the alignment and the overall kind of just shape of the object here. And obviously, this is a standard color map where red and yellow hues are high, green is within a tolerance.
I'm assuming the data can be your results data, your scan data, and so forth can be exported?
Absolutely. Okay. Yeah, we can save it out as a PowerPoint or a PDF, or we can actually take all of this data in the charts and export it into something like Microsoft Office products, so we can display it that way as well.
Okay.
Okay.
Talk a little bit about what we were doing earlier. Is you were kind of manually rotating this in order to fill in all the shadow areas. I think you said that one of the options coming up is going to be a rotary stage, right?
Right. We're going to have another package for some of our customers, so that we'll actually have a turntable that's driven by the software. And it basically lets you do two things. First of all, if it's a known rotation amount, it helps out with the alignment a lot. And then it also, because this is all driven by the software, so you can kind of pre-program it, say that I want it to rotate 60 degrees and do a full 360 scan, or kind of customize some of those options. And then we also have, the other nice thing about having the rotation, especially with the inspection package, is that it's more automated. You can kind of just set it up to take all your scans for you instead of having to manually do every single one of them.
Sure.
Yeah.
Now, we're obviously using the stationary. Will this function as kind of a handheld scanner? I mean, could you just hold it and point it, or does it need to be stationary each time you're taking an image?
It does need, it doesn't have any image stabilization like that. It does need to be standalone, or kind of freestanding by itself and in one location. Now, that doesn't mean to say that I can't move this and pick it up and scan another area on the part.
Right.
We just need to make sure that we know how to align those two scans. So either get a lot of good, interesting overlapping data of solid kind of prismatic features like that,
or paper targets.
Exactly.
Okay. Yeah. Now this functions right now. It's working with Geomagic Verify, but the capture system actually ties into other Geomagic software as well, right?
That's correct. All of the scan-based design products that we offer, like Capture for SolidWorks or Geomagic Design X, or the Capture for Space Claim, or the Design Direct product that we have. So we can do scan-based design with it. We also do have another scan to inspection package called Geomagic Control that is more of a hands-off automated kind of a assembly line sort of inspection package. So there's scripting involved in that. There's Python scripting. There's kind of a lot more automated things. So
so you might have something like this set up on like you said, a conveyor system. A part moves into place. It captures data, inspects it, kind of thing?
Yeah, yeah. Okay. So we can either do a single scanner like that, or we can actually set up a batch of scanners together.
Okay. All right. Before we wrap up here, bullet points. What do you want people to walk away with?
Okay, so we've got the capture device. It works with all of the Geomagic software. Prices start at about $15,000, go up to about $30,000, depending on what you're looking for. Very, very high accuracy, really simple and intuitive to use because it works directly inside all of the software. There's no kind of interface that you need to do data exchange between. Really cool piece of equipment.
All right. Well, Sean Parker, 3D Systems.
Yes, sir.
And the Capture 3D Scanner and Geomagic Verify. Thanks a lot for showing it to us.
Thanks for having me on.
Okay. Back to you, Mike.
All right. Thank you, Dirk. Thank you, Sean Parker of 3D Systems. That's the Capture Scanner. Another great tech corner there from the guys, Dirk and Sean. And Dirk, thank you for doing that.
Sure.
I think we always enjoy having a tech corner.
Yeah, it's fun to get equipment in here.
This was a
I just wish they'd leave it behind.
Yeah, that's right. Let us play with it. All righty. Well, that's our show for this week. But before we go, we'd like to thank today's sponsor. HEXAGON Metrology is committed to helping you control your processes, enhance the quality of your products, and increase efficiencies. They empower you to stay one step ahead of a changing world with their wide range of product offerings, nearly 200 years of expertise, and an extensive support network. HEXAGON Metrology, where quality comes together. For more information, just click on the banner ad just below or just to the right of this video player screen right down there.
That's right. And well, this is the end of our show, and we're still in the middle of 3.14.
Yes, we are.
That's right. Happy Pi Day.
So
thanks to Dan Nelson, to Sean Parker from 3D Systems, and to all of you for joining us today. And hey, have a great weekend.
Yeah, we'll see you next week with another big week at QDD, and next Friday here at QDL. So
3.14 to you.
That's right. See you next week. Bye.
Fire!